All right, we're going to start here on angles and parallel lines. I've drawn this little 3D box over here to just kind of show you guys where each of these angles, where each of these lines could occur. So if we talk about parallel lines first, parallel lines are coplanar lines that do not intersect. So I could have this line up here and this line here as parallel. I could also have that one there, and this one down here would be parallel. Our plane would just cut through. So our skew lines are going to be lines that are non-coplanar, but that still never touch. So maybe I've got this one up top here, and this bottom line down here. Those would be skew. And then our parallel planes will be planes that are parallel that will never touch. So maybe the top and the bottom of this box. So we're going to move into transversals and the angles that are created. For our transversal, we are talking about this line here that intersects both lines. It is a line that intersects two or more coplanar lines at different points. Now, notice that I drew these lines not parallel. I want you to make that distinction in this particular case. So we have corresponding angles, and they're angles that occupy corresponding positions. So we're going to follow our transversal, and with the top line, if I choose this that's in the top left, then I'm going to choose this one that's in the top left. And in the same way, if I choose the bottom right here, then I'm going to choose the bottom right here. And there are two other pairs of those angles there as well. Alternate interior angles are between the two lines and on opposite sides of the transversal. So we're inside the sandwich here and on opposite sides of the transversal here. And then here and here. Okay. Alternate exterior angles are angles that are outside the two lines and on opposite sides of the transversal. So we are on the outside of the sandwich here, and I want to be on the outside of the other on the opposite side. So those two would be alternate exterior angles, as would these two. And then I have consecutive interior angles, which are same side interior. Those two terms are interchangeable. They lie between the two lines on the same side of the transversal. So if I choose this angle here, I want to stay on the same side of the transversal on the inside here. And this one and this one. So this would be, most often you're going to hear them called same side interior. That's what I usually say, just because that's how I learned it initially. All right, if there is a line and a point not on the line, then there is exactly one line through the point that is parallel to the given line. So we're going to start here with our line and a point. And what this is telling us is that there is exactly one line through that point that is parallel to the original line. If there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So in the same way, we're going to have our line and a point, and we will have exactly one line that is perpendicular. I'm going to draw this one and then move it over. Right there. Okay. So we're going to find the line parallel to MN. So here is MN that contains point J. So I see JL. Those two will be parallel. And JL. We're going to assume that these are all part of a line. So I'm going to go ahead and put that distinction above. Find a line skew to MN that contains O. So that will be OK or KO. Find a line that appears to be perpendicular to line NM, MN that contains L. So that would be LM. And name a plane that contains point K and appears to be parallel to plane MNO. So MNO is this plane on the back. So I want to look at this plane here, and that will be JKL. All right, name a line parallel to line AF and containing E. So AF is here, E is here, so this would be EJ. Name a line skew to AF that contains point J. So if I back this off, then if I contain point J, it would have to be this line here, line JI. And name a line that appears to be perpendicular to AF that contains point B. So that would be BA. Name a plane parallel to FGH. That's that plane on the back. So remember that to name a plane, we're going to use 3 points only from this front pentagon. So it could be A, B, C. It could be any combo of those 5 letters. So given the figure, name a pair of parallel lines. We have line AB and line CD. And to say that they are parallel, we're just going to put these slanted bars in between them. Using the given figure, name a pair of perpendicular lines. Well, we've got the indication here that line AB is perpendicular to line AC. And our other question is AC also perpendicular to CD? And our answer to this is yes, because they are all coplanar. If a line is perpendicular to one of the parallel lines, then it has to be perpendicular to the other, as long as they are coplanar. So only when coplanar. All right, so find the indicated pairs. Let's talk about each of these. I'm not going to write down all of them because there are lots of them that we could take. I would encourage you to grab like a sticky note and cover up some of these angles. So I'm going to see if I can do the same thing here. All right, I think that this will work. Okay, so if we have 4 lines, we really only need to focus on 3 of them. So I'm going to cover up this bottom section for just a little bit. And let's focus on what's on the top. So if I want alternate interior angles, and I say let's look at angle 4, then angle 5 would be an alternate interior angle to angle 4. But then if I move my sticky note over here, then what we see is that 9 is also an alternate interior angle. If we look at angle, let's see, angle 7, then with these 3 lines, angle 2 would be alternate interior. And if we move our sticky note, then I could also see that 7 and 14 are alternate interior angles. We only can use relationships created with 3 lines. So if I take, let me delete this out of here. Let's say I look at angle 4 and angle 13. These have no relationship. None of these relationships right here have anything to do with 4 lines. So we need to look only at 3 lines at a time. Let's take a look at alternate exterior. So if I take a look at number 1, then if I follow this horizontal transversal, 1 is going to be alternate exterior to angle 8. And if I look at the vertical transversal, 1 will also be an alternate exterior angle to angle 12. 6 and 11 would be an example of angles that are created by 4 lines. So 6 and 11, although they're on alternate sides on the outside, those would not have that direct alternate exterior angle relationship. Corresponding angles, if I take a look at angle 1, then if I follow the transversal to the right, angle 5 would be in that same location. Or if I follow the transversal down, angle 9 would be a corresponding angle to angle 1. And then for same side interior, I've got angle 3. And if I follow my transversal, then angle 9 would be a same side interior angle to that one. And it actually wouldn't have another one. So if we take a look at, let's say, angle 4, if we follow our transversal to the right, then angle 7 would be its same side interior angle pair. Or if I follow the transversal down, 4 and 10 would also be same side interior angles. Now, the last thing that I want to put down here at the bottom, I'm not going to list out all the vertical angles, but just remember that our vertical angles are always congruent, and our linear pairs are always supplementary. Okay, these are true all day, every day. Okay, nothing else that we have mentioned prior has anything to do with the value of an angle. So the last piece that we're going to go through has to do with parallel lines. So this time, whenever we create our lines, I want to make them parallel. And we're going to go ahead and designate them as parallel with those extra little things there. And a transversal. So I'm going to take these and I'm going to copy paste. Okay, and notice at the beginning of all of these statements is if 2 parallel lines. So if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So not only can I come over here and mark some corresponding angles, I can also mark them as congruent. Our shorthand version will be if parallel, corresponding angles congruent. If 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So if I choose this angle here and this angle here, then if my lines are parallel, those 2 angles are congruent. If parallel, alternate interior angles congruent. If 2 parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So if I pick this one here and this one here, if my lines are parallel, I can say that those two angles are congruent. Notice that if-then conditional. If parallel, alternate exterior, angles are congruent. And the last one changes it up just a little bit. If two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. So if I take this here and this here, I don't want to mark them congruent. They are supplementary. So our shorthand, if parallel, same side interior, angles, supplementary. And then let's apply this. I'm going to be super particular about using the if parallel. Okay, so everything has got to follow the if parallel because this is only true if our lines are parallel. If you look back up here where we first started, these lines are not parallel and these corresponding angles are not congruent. You can look at these two and see here and here that those two are not congruent to each other. They are only congruent if our lines being cut by the transversal are parallel. So let's get some practice in writing down the y. So if angle 7 is 75, find the measure of angle 1, 3, and 5. Tell which postulate or theorem you would use in each. So if I want to compare 7 and 1, my lines are parallel, and these are alternate exterior angles. So for angle 1, we can say if parallel, alternate exterior, angles are congruent. So angle 1 would have a value of 75 as well. If I want to look at angle 3, well, if I compare 7 and 3, those are what we call corresponding angles. So angle 3, our reasoning would be if parallel, corresponding angles are congruent, and angle 3 would also have a value of 75 degrees. And our last one is angle 5, and if I compare angle 7 to angle 5, those are vertical angles. So vertical angles are congruent, and 5 would be 75 degrees as well. Notice we don't need the if parallel for the vertical angles. The vertical angles are always congruent. So the measure of 3 of the numbered angles are 125. We want to identify those and explain why. So let's see, let's check vertical angles first. So angle 1 would be 125 because all vertical angles are congruent. Let's check our angle pairs. So 125 and 7 would be the same. So angle 7, because they are in corresponding locations. So if parallel, corresponding angles are congruent, and this one would be 125. And angle 5. So let's base everything off of our original 125. So if I want angle 5, then I'm going to use alternate interior angles. If parallel, alternate interior angles are congruent. Okay, and the last one, find the value of x. This 113 and 3x minus 4 are alternate exterior angles, and because our lines are parallel, I know that if parallel, alternate exterior angles are congruent, so I can set those equal to one another. 113 is equal to 3x minus 4. and we can solve for x from there. So if I add that 4 over to the side, I end up with 117. And 117 divided by 3 will give me 39.